Alrighty, welcome back, boys and girls. It's your main math man, Miss Shane, coming to you live from Alameda International High School. In this video, we're going to be working with simplifying some rational expressions. And so what that is this. So we're going to start with a little bit of vocab so that way we know what we're doing. So again, you have a rational expression is going to be a fraction. You can notice how it has that word ratio in fraction. We're going to say it's a fraction with variables, and it could be in the numerator, it could be in the denominator. So again, make sure you're thinking an expression is a set of quantities without that equals symbol. So we're going to say, again, the kind of example looks like that, 2x plus 3 over x minus 2. But make sure you're saying, again, any fraction must not have zero in the denominator. The reason why this works, again, it's going to give you kind of like an error in your calculator. So if you were to say something like 1 divided by 0, you're going to have an error. But again, you can kind of look at what the graph would look like. If I have something like 1 over x, 1 over x. Again, when we go to graph it, notice how it creates that, it's called an asymptote because it makes an undefined value. Again, that kind of, it would be impossible to get a value because it spikes through the whole way. And so that's why we aren't able to divide by 0, but that's okay. As long as we're being careful of that, we'll be good. So in this example, we'd have to say, hey, we have to put a restriction on that value of x. So that means this, we would have to say for this one, x could not be equal to 2. So anytime you see that equal sign with a line through it, that just means is not equal to 2. And that makes sense because if we plugged in 2 minus 2 is 0, which we cannot have. All right, so again, make sure you're kind of thinking back to before when we were doing our factoring. Again, we're looking for that greatest common factor that we can divide out, and so that way we can simplify our expression. So in our numerator, we have 20x squared times y to the third power, all divided by 16 times x to the fifth times y. And so what I can do is this, I can break it apart if I need to. I can break it apart and have that prime factorization. So if I needed to, I can break apart my numerator. So I could say I have 2 times 2 times 5. I have 2 x's, so times x, and then I have 3 y's. If I'm looking at my denominator, I can say, all right, I have 2 times 2 times 2 times 2 for 16. I have 5 x's. Again, making sure they're multiplied together. And I can say I have times y for that last term. Just be careful when you are working with this. Again, that fraction bar in the middle, it just means you are dividing. So that means this, I can kind of cancel out some of those common factors. So I can cancel out a 2 from the top and bottom, cancel out 2 from the top and bottom. Similar idea for the x's. Again, make sure you can cancel out 2 from the top, 2 from the bottom, and I can cancel out 1 y from the top, 1 y from the bottom. So again, if you're struggling with this, again, make sure you're doing those exponent rules. It's basically this, I'm looking at my exponents of those variables and I'm saying, okay, since I'm dividing, I can subtract those exponents. Meaning I would do 5 minus 2 is 3, and I would do 3 minus 1 is 2. So I'd have this as my simplified expression. I'd have in my numerator, I'd have 5y squared all over, and then let's do 4, and then I have x cubed. So again, make sure you're seeing how that works. I did 5 minus 2 is 3, and then I did, for the y exponent, I did 3 minus 1 is 2. All right. Make sure you include that restriction because we can't say we have a denominator 0, so we would say, okay, look at our denominator, what value would make it 0? So we'd say, hey, we'd have to restrict it and say x cannot be equal to 0. So that's going to be part of your answer for each of these. In that second example, it reads like this. It has x squared plus 2x minus 15, and then the denominator has x squared plus 11x plus 30. So make sure you're doing those factoring ideas that we had from before, so build your foundation. So I'm going to say I can rewrite it like this. I can have two sets of parentheses. I have x in each of them because I'm unfoiling. So make sure if you need to, you can always double check your answer because you're saying, okay, I can FOIL it out and I should end up with what I started with. I look at my product and I say, okay, I need two numbers multiplied together to get negative 15. So that means they're going to be different signs. And I can use that sum of 2 to say, hey, my sum is going to be positive, so the larger number goes with the positive. So I'd say my two numbers are going to be positive 5 and negative 3. Underneath of it, I can have my denominator. Look at your product is going to be 30, where their sum is 11. So I can have x plus and then x plus. And then I need two numbers multiplied together to give you 30, whose sum is 11. So I have 6 and 5. And so now what we can do is this. We can kind of cancel out these packages, meaning these sets of parentheses. Make sure you cancel out one from the top, one from the bottom, and make sure you do it one at a time. So I'm going to say, hey, what's in common between the numerator and the denominator? I'd say I have an x plus 5 in the top, x plus 5 in the bottom. And then whatever I have left over is going to be my new rational expression. So I'm going to say I have the expression x minus 3 over x plus 6. Make sure you write your restriction. So I'm going to say x cannot be equal to negative 6. The reason why that is because if you look at our denominator and our answer, we couldn't plug in a negative 6 because it'd be equal to 0. All right. In number 3, again, make sure you can always double check. Can I factor out anything from that numerator? Well, I can factor out an x from each term. So what I'm going to do is this. I'm going to say, hey, this is the same as factoring out an x, and so my new exponents are going to be x squared, x to the first power, and I just have 12. So my new quadratic is going to be x squared plus 7x plus 12. So now it's a little bit more easier to work with, so I can work in that numerator, being able to unfoil it. So I have x still on the outside, and I have two sets of parentheses. Make sure you look at your product. So my product is 12, or the sum is 7. So that means I'm going to have the same sign because my product is positive, and they're both going to be positive since my sum is positive. So I can say two numbers multiplied together to give you 12 and their sum is 7 would be 4 and 3. And then if you look in your denominator, I can say, hey, what can I factor out? What would be the greatest common factor of 5x plus 20? Well, I could factor out a 5 from each of those terms. I'd have 5 on the outside, and then I had to have x plus 4 in my parentheses. Again, make sure you're canceling one package out at a time. So in numerator, denominator, whatever's left over is going to be part of your answer. So I have x times x plus 3 all over 5. And I don't have to have a restriction for this one since, again, our denominator is just 5. And then for the last one, again, that's the difference of squares. So make sure you're saying that those are super simple to be able to factor. Again, our product is negative 81. That means I need two numbers that are the same because our middle term is 0x, and I can say they have different signs. I can have it like this. I can have x plus 9 and x minus 9. Again, those are real simple to be able to factor out. And then in our denominator, again, have your foundation. I have x and x. Again, our product is negative 99, so I have different signs. And I can say, all right, I need to have our sum is 2. So that means the larger number is going to go with the positive. So I can have positive 11 and negative 9. Make sure you can make or cancel out your packages. So I have x minus 9 in the top and bottom, so those cancel out. And I'm left with x plus 9 all over x plus 11. Make sure you write your restrictions. So I'm going to say x cannot be equal to negative 11.